A message queue is a system that facilitates asynchronous communication between different parts of an application, allowing them to send and receive messages without being tightly coupled. This makes applications more scalable, fault-tolerant, and easier to maintain. For more tech interview materials, please go to our website at bowsy8.com. How a message queue works. 1. Message sending. A producer, sender, creates a message and sends it to the message queue. 2. Message storage. The message queue holds the message until it is processed by a consumer, receiver. The message queue ensures the messages are stored reliably and, depending on configuration, can persist messages to disk for durability. 3. Message consumption. A consumer retrieves and processes the message. Depending on the queue settings, messages can be delivered in one of several modes. At least once. The message is delivered at least once, may be redelivered if an acknowledgement isn't received. At most once. The message is delivered once at most. Risk of loss if the consumer fails. Exactly once. The message is delivered and processed only once, ensuring no duplication. 4. Acknowledgement. After successful processing, the consumer sends an acknowledgement, ACK, to the queue. The message is then removed from the queue. 5. Retry and dead letter queues. If a message fails to be processed after several attempts, it can be moved to a dead letter queue for further inspection. Below are the major components. 1. Producers. Applications or services that generate and send messages to the queue. 2. Message queue. Broker. The core system that holds messages temporarily until they are consumed. 3. Consumers. Applications or services that retrieve and process messages from the queue. 4. Messages. The actual data or payload sent from producers to consumers. Each message typically contains header, metadata like timestamp, priority, or routing info. Body, the actual content or payload. 5. Queues. Data structures where messages are stored. Different types of queues include FIFO. First in, first out messages are processed in the order they arrive. Priority queues. Messages with higher priority are processed first. 6. Exchanges, for some systems like RabbitMQ, responsible for routing messages to the appropriate queues based on rules or patterns. 7. Dead letter queues, DLQ. Queues that store messages that cannot be processed successfully after multiple retries. 8. Acknowledgements, ACKs. Signals sent by consumers to confirm successful message processing. This ensures reliable delivery. Some key concepts in message queues are 1. Asynchronous processing. Producers and consumers operate independently, improving performance and decoupling services. 2. Scalability. Multiple producers and consumers can work in parallel, making the system horizontally scalable. 3. Durability. Messages can be persisted to disk to prevent loss in case of failures. 4. Reliability. Features like retries, acknowledgements, and dead letter queues ensure messages are not lost. 5. Decoupling. Producers don't need to know the specifics of consumers, simplifying system design and maintenance. Example message queue systems include 1. RabbitMQ. Open source, supports complex routing with exchanges. 2. Apache Kafka. Distributed, designed for real-time data streaming and high-throughput workloads. 3. Amazon SQS, simple queue service. Fully managed cloud-based queue with high durability. 4. ActiveMQ. Open source, supports multiple messaging protocols. Thanks for watching. For more tech interview materials, please go to our website at bowsy8.com.